seaweeds, but what is it?
This is Sargassum, is abundantly found in seas and oceans.
But last time I saw 2 species of Sargassum. So how much Sargassum there is in the world?
Oh, more than 300 species are currently found around the world. They belong to the family of brown algae and are pelagic, which means that they are not fixed on the seabed but float freely on the surface of the ocean and following the currents.
Scientists suggest that the influx of Sargassum in the Caribbean is due to a rise in water temperatures and low winds, which both affect ocean currents. So, in essence, species of the Sargassum are becoming entrained in currents which head towards the eastern Caribbean islands. But because this problem has arisen quickly, new information is constantly being uncovered. Scientists at the University of Southern Mississippi have even come up with a new theory about Sargassum's origins in the Caribbean. Some believe that it was brought into the eastern Caribbean through the North Brazil current, and because it thrives in warm, nutrient-rich water, the Sargassum simply spread through the region. In Guadeloupe, there is 2 species of Sargassum. Moreover, in 2011, in the Mexican Caribbean Sea, started experiencing climate change impacted by a sudden flux of Sargassum.
The general morphology of these 2 species of Sargassum is very similar. They are both brown to yellow colored macroalgae that do not have a spike to attach to a substrate. They have ramused and entangled side branches on which are attached many floats called gas vesicles or areocysts. They allow them to float. These algae generally do not have a main axis, but instead form a cluster of branches. Their size can reach from 15 cm to 1 meter.
The floating seaweeds will grow and provide feed for microbes and allow the turtles, marine birds, crabs, or also other species to breed in it. So the Sargassum provides ecological function at sea, like a proper habitat for epipelagic species. They are home to many crustaceans, mollusks and fish. They attract larger fish which feeds under the floating rafts. Therefore, when these algae arrive massively on the coasts, they gradually die off, leading of health and economic consequences that can turn out to be catastrophic. The impacts of Sargassum's sudden influx lead to biodiversity loss, degradation of coral reefs and associated ecosystems, such as mangrove ecosystem. In addition, Sargassum can be a transport for introducing exotic and invasive species, like the lionfish in Guadeloupe. A study examining the Sargassum on the coast of Caribbean countries found that the seaweed produces large amounts of toxic gas after 480 hours on the shore, including hydrogen sulfide and ammonia. In Guadeloupe, doctors reported more than 3,341 cases of acute exposure to the toxic gas between January and August 2018 in Martinique, more than 8,061. Mangrove is a type of forest that grows in the intertidal zone of tropical and subtropical regions. The mangrove ecosystem is dominated by mangrove tree as the primary producer, interacting with associated aquatic fauna, social and physical factors of the coastal environment. The occurrence of mangrove is influenced by tidal regimes and certain water parameters. Mangrove trees have physiological and morphological adaptation to the environment stresses of their intertidal habitats of high salinity, low oxygen, poor nutrient availability, and substrate mobility. Moreover, its geographical distribution is influenced by temperature and salinity levels. Mangrove forest plays several important ecological roles, such as mangroves provide nursery grounds for fish, prawns, and crabs and support fishery production in coastal waters. They provide hiding places for young animals and abundant food supply that comes from the mangrove leaves. For every hectare of mangrove cut down, a corresponding reduction in fish catch is estimated at 1,008 tons per hectare per year. And mangroves produce organic biomass. Also, Dixon, 1969, estimates the value of a complete mangrove ecosystem to be in the range of around 500 to 1,500 USD per hectare per year. So that's a really huge value. In the last decades, large areas of mangrove forest have been destroyed by overexploitation and conversion to other uses. Human activities remain a major cause of degradation and loss of mangrove ecosystem in all parts of the world. But this ecosystem is also sensitive to several natural factors which can lead to a dieback of the mangrove forest. What is dieback? Dieback is a disease which affects woody plants, and it is characterized by progressive death of branches, roots, or shoots, and starting at the tips. While there are many factors that can affect the mangrove trees, it is now completely assumed that an overabundance of rotting sargassum can lead to the mangrove degradation.
Indeed, with the action of the currents, the swell and the wind, sargassum raft penetrates the mangrove at the seafront and settle on the aerial roots of three red mangrove trees, stagnate in the water column and muddy sediments. The particular entanglement of these roots traps sargassum algae, which are not easily evacuated to the offshore during favorable swell. When sargassum are trapped in the mangroves and stagnate between the substrates, the roots, and the water, they start to decompose quickly. The decomposition of organic matter consume oxygen and therefore cause a sharp decrease in dissolved oxygen in the water until the environment becomes anoxic. The mangroves are therefore relatively well adapted to poor oxygen living conditions. However, in the long term and on a recurring basis, this lack of oxygen proved to be a limiting factor for the development, the growth of trees, and the regeneration of the population, thus slowing down the production of biomass. Crab populations found in mangroves are severely affected. Dead crabs are seen on rotting algae on shores or in mangroves. Their shells are softened. The release of hydrogen sulfide during the decomposition of sargassum is probably the cause of this phenomenon. Crabs were affected by the release of hydrogen sulfide. The semaphore feeder crabs seem to have been more resistant to the impact of this phenomenon. They even dig their seeds in seaweed that is decomposed or in an advanced state of composting. But the resistance mechanism and their tolerance threshold have not been documented to date.
In the case of Petit Trou, the evidence of exposure to the gaseous emissions is seen in the discoloration of gneiss holding together the areas below boardwalk, which runs as a well-organized access network through the mangrove that borders the tobacco plantation development. The lagoon location along the Atlantic coast exposes its mangrove to an annual influx of Sargassum deposits. This barrage creates several effects, some of which are detrimental to the survival of the mangrove and the biodiversity that exists in the water-based areas of the ecosystem.
Solutions are put in place to limit the abundance of sargassum on the beaches. Sargassum is collected on the beaches in a mechanized way. It can also be collected at the sea thanks to floating booms. Several variations of sargassum are possible. Valorization in agriculture and breeding, the valorization in bioplastic, cardboard, paper or coal, or their methanization.